Hi, so in this video I'm going to show you how to create the OCR Plumb Bob. We're going to use Shaper 3D on the iPad, and then the finished file we'll take over to Bamboo Studio, which is a bit of slicing software used for our Bamboo Labs A1 mini printer. As I've said in some of our previous videos, this isn't actually a beginner's course into Shaper. We really need you to look at the pizza cutter project or also the rubber stamp project, and that'll give you a good fundamental knowledge on how to use Shaper 3D. So speedily getting into it, we've opened up Shaper 3D on our iPad, and I'm just going to hit a new file and it'll bring up a brand new workspace. I've got the OCR engineering drawing here, so I know all the measurements for all the correct parts, and I'm just going to basically start scribing that into the program. Instead of looking down on the piece like I normally would from a bird's eye view, this time I'm actually going to do a side profile. So I'm going to go and select the front view, bring it down here. I'm going to start annotating the lines. I'm only going to be doing half the profile of this piece, so some of the measurements I'll be dividing by 2, but it'll all make sense when it's finally created. So I'm going to hit sketch and my lines. So first of all, I'm going to go, let's do the bottom 10 millimeters, so from the middle there, out, select that and 10. Okay, that line then would go up to 59.25, so 59.25, brilliant. Okay, next one, we need to come out, it'll work out to be 9 millimeters. So I'm just gonna type it in this way, that's it. And in total, the whole piece is 120 millimeters. So what I'm going to do for this one is I'm actually going to go back down to the start line and draw up a line, 120. And now I've actually got a line there, which is the length of the piece. There's 2 more little lines to put in. One is a 20 mil lines in this direction here, 20 mil. And then I join those 2 up. And I should have an angle between those 2 lines of, it'll be 25 degrees, because the full top radius would be 50 degrees. So if I click these 2 lines, it's saying it's almost like 1/1000th of a millimeter off. So I'm just going to put 25 in there, which I'm happy with. Exit sketching. And you should be able to see I've got a nice shape there, the side profile of half of our Plumb Bob. So to actually create the 3D form of this Plumb Bob, I'm actually going to revolve that one surface in a 360 degrees on the vertical axis that we have here. So the way we do it, we would select the surface we've just made. We would find our option of revolve. And then what we want to do is select, well, I already selected it, select the shape and then select the axis. And what it's going to do is do a whole revolution of 360 degrees around that axis. If we hit done, you'll see it's now created that lovely 3D profile that we need. I personally like to work a little bit cleaner in Shaper, so a lot of these measurements are associated with the drawing that you just did. So if you go to items and just hide the sketch that we did, it will hide all the details of those measurements and just show you that body that we've created. There's just a couple of more bits, we need to add, and it's a little radius on this inside edge, a radius on this outside edge just here, and a radius on this bottom edge. So nice and easily, like we've done before in previous projects, select it, drag it out. It's saying it's a radius of 1 millimeter there, which is correct for that one. I'm going to come up here, select the inside edge. That one's 2 millimeters, so 2 millimeters, perfect. And then it's the same with this outside edge just here, but I'm just going to make sure that's just selected, and 2, perfect, and deselect. Perfect, that's exactly what I needed for the outside form. So the next bit is actually one of the most difficult bits. In the end of the piece here, in the end of this shaft, there is a metric 10mm threaded section which goes up into the piece for 20mm. With Shaper, there's not really an easy way of doing a threaded surface. You actually have to do this quite manually in quite granular detail. So I'm going to show you how to create the threaded section in this piece, and I'll try and explain as we go along some of the measurements, etc., and why we do it. So as I've finished with this piece just for now, I'm just going to move it out of the way. So I'm just going to double click on the body and just drag it over to the side. Just keep it out of the way. I know I can hide it, but I'd rather just see it and it just be there. So I'm going to hit deselect. We're going to start now drawing this threaded section. So the first bit, I'm going to go to the top view, and I basically want to do a circle, and I'm going to bring it over. And I'm looking for an 8.8mm hole. Circle right there, and then I can extrude that. The length of the hole that's going to be inside the piece is actually going to be 20mm, but I'm actually going to do 25 because we can trim the excess off in a minute, and I'll kind of make sense of that in a little bit. So 25mm. And that's the length of the hole that we're going to create. The next thing is we're going to create the thread, which is going to ride along the edge of this cylinder. And we have to be quite specific with this because we're using a metric thread system. And with an M10mm thread, we're looking at a pitch of 1.5mm. And that is basically one whole turn of the thread every 1.5mm. So I'm going to show you how to do that now. So I'm going to go back to front mode, and I'm going to go to the top corner of our piece. I'm going to basically draw a triangle, which is going to be a profile of the thread. So the best way of working this out is I know that I need to have a line that is going to be 0.9mm, because that's actually going to be the measurement of the thread. So 0.9, and then I'm going to draw two lines off of this to basically create the triangle of the thread, and I want that thread to actually be an exact measurement of 60 degrees between the two. So I'm going to draw a line first, draw it down, and then I'm going to select the two, and then I'm going to create half 60 is 30, I'm going to go 30, perfect. So I know this is this half, and then if I do a line over here, join it with that one, and the two measurements between there is going to be 30 as well. All I really want is to make sure that those two lines are joined up as well. So I'm just going to do a line in between those two. Help if I had them joined, there we go. And that is the profile of the threaded section, and I'm going to show you by using the revolve option again. We're going to make a thread all the way around here. What I'm going to do is select the triangle that we've just made, and then I'm going to find that revolve tool again, and we're also going to do it around that middle point. And you can see it's basically drawn that thread as a single ring along the top. We need to change that. So at the moment where the depth of the piece is 0mm, we're going to go all the way down to -25, because that's the length of the piece. And you can see now that single thread is only rotating once all the way through the length of 25mm. And that wouldn't be a very good thread for what we need. So we know that for the thread that we're looking for, there'll be a whole revolution every 1.5mm. So I've done some quick maths with regards to the measurement that we need of how many rotations we do like this. And actually we would need it to be a figure of 13,500 degrees. Okay, and now you can see it's revolved around the piece in an accurate way. I'm just going to hit done so we don't lose that. And you can see that fundamentally looks like any screw or bolt thread, and we know we've pretty much matched an M10 thread pattern there. Like I said before, I like to just remove the drawing of the triangle that we did. Well, more hide it than remove it, so I'm going to go to the hide for that sketch. And at the moment, the inside core that we created is a separate body to this outside. So what we're going to do is union both of them. So what we can either do is go down here and select union and select that top column that we created and then the thread. And then if you hit done, that is now a single body, which we can use a lot more easily. Now this shape is ready to subtract from the piece that we made earlier on. So if I just bring this back over, just a little bit closer. So there's a nice way where we can align this piece right to the end of the piece over here, because we want to subtract it from this end. So the best way of doing it is we're going to select the end just here and go align. And you can see it's selected the very top part. So now if I select the bottom middle of this piece, it's going to place it directly against that surface, dead center as well, which is exactly what we want. So I'm going to hit done. So now we need to get this threaded part in a position exactly to where it needs to be in this body here. So I said that the hole depth should be 20 millimeters. And I know at the moment that our threaded part doesn't actually go into this body yet. So we can actually move it really accurately 20 millimeters up in that axis, and it should go directly into the place we need. So I've selected it all, and then I'm just going to move it up, and on here I'm going to select 20 millimeters. And now, if you can see there, it's moved it up into that body, and there's there's 5 millimeters extra just sticking out the end there. So I'm just going to deselect that. And now it's just the simple bit of subtracting this shape from this shape. So what I would do is I would select the main body of the plumb bob, and then find the subtract tool, which is down here. So it's, because I already pre-selected it, it's saying that's the bit to keep, so it's got a plus there, and we just now need to tap once on the bit that we want to subtract, and we know that it's that threaded section. Hit OK. And now if we look into the end, you'll see there's a really nice M10 pitch of 1.5 threaded hole, internally threaded in there, all the way down to the length. And now that matches the engineering drawing that we had perfectly. And now all we need to do is export it so we can take it into the slicer software. So to simply export this in the right file that we need, there's 3 little dots in a circle at the top here, and you go down to export to, and then from there you hit export. And there's 2 main file types that I like to save to bring them into Bamboo Studio. There's an STL file or a 3MF file. So for this time, I'm just going to use an STL. I make sure the resolution's set to high, and then just export. You save it with a name, something practical. So you would write it down here, put it into the right place that your teacher's asked you to save it to, and then simply hit save. And then we can take that file onto the computer that has Bamboo Studio and get it ready to slice up the 3D file ready for the 3D printer. So I've come over to the desktop PC that's running Bamboo Lab Studio. And like I said, this is a bit of software that will create a sliced file for the 3D printer to work from. And I'll try and explain as we go on what it's going to be doing. So first things first, I'm going to hit this green button in the top which says create new project. And here you can actually see the build plate of the Bamboo Lab A1 Mini. So this is essentially the base of what we're printing onto. They come in a few different variations. I've set it to the smooth version, which doesn't leave a sort of rough finish on the underside of a piece that's printed. It should be just relatively smooth. We do have another one that does have a texture. Sometimes that's actually a good thing because it's a better bed adhesion, so you won't have any 3D prints falling off during the print. It'll stay quite solid. But for what we're printing, this flat smooth one's absolutely fine. You can also select here what type of filament you're using. We use a PLA plastic, which is a derivative of cornstarch, and it's used a lot across the industry with regards to prototyping. There's other properties with other plastics, but this is the one we're going to just use for now for this. You can also set the size of nozzle that you're using. That's the hot end that the hot plastic gets extruded through. At the moment, that's a standard at 0.2 mil. And then there's a lot of other different settings which you can use with regards to your design to achieve different things, but we'll talk through those in a minute. So first things first, what I've got to do is bring in the Plumb Bob. So that file that we saved, I'm just going to bring it in and drop it on the bed. And there you can see the 3D render of the Plumb Bob just sitting on the bed like that. This is actually the orientation in which I want to print it. If I had this turned upside down, it would be very hard to print this top surface nice and smooth inverted without lots of supports, which I'll try and explain again in a little bit. But this is the best way of basically printing the Plumb Bob as we have it. So you can see at the bottom there, we've got the threads that'll be against the bed, and then the shaft comes all the way up to the head there. Okay. So the best way to view a 3D printer is a bit like a glue gun being on a computerized controller. So if you imagine a glue gun traveling around a set path, and then after it's drawn a shape, it raises up a little bit and draws another over the top, then lets that cool, and it goes up and carries on until you start building this 3D form. Obviously, that's the crudest way to sort of explain what a 3D printer is. It's doing it in very fine tolerances with temperatures and speeds and sizes being dialed in really correctly to get a decent looking print. The more layers you have in a print, the more time it's going to take, but also you're going to get a better resolution of print. If you had bigger distances between each of the layers, it would print quite quickly, but you'll notice a lack of quality there. So depending on if you're doing something for a draft prototype or something that's a finished article, that's where you would change around the layer height. Pretty much standard on this printer is a layer height of 0.2 millimeters. So it will do a layer every 0.2 millimeters. So what I'm going to do, I'm just going to check that this is all set to standard, and I'm going to hit slice plate up here, and you'll see it convert this 3D shape into a sliced image. So this orange shape now is actually built up of lots and lots of individual layers, and it can now give us estimated times, how long it's going to print, and it also can have a color key, and you'll see this inside in a minute, of what the different types of print are. So we never really print things as solid material. This is actually going to be hollow with like a grid inside. And I'm going to show you that, because if I drag down on this bar here, and if you look at the top, you can start seeing every single line that creates this piece, and you can see the infill there, you can see it come down, and then you should be able to start seeing the threaded section that we created right up to that initial base layer, which is generally made to adhere to the bed. If I bring it back up to the top, I should be able to tell you how many layers there are. So it's 592 layers in total to make this plumb bob. So as you can imagine, the printer has to work quite hard to get even something this small created. So we talked about layers, how the image is broken up into lots of little layers. What's quite nice about this program creating a bit of G-code to control the printer is you can actually add in pauses. So say if you had something that you needed to drop in, be it a magnet or a mechanical fastening, you could set a pause up at a certain layer. It would bleep at you, so it would knew it would get to that layer, and then you'd insert what you needed to insert and then hit resume, and it would print the rest of the piece. So generally that's all specific on what you're designing. Sometimes it can be counterweights, like I said, magnets, mechanical fixings, things like that. But it's quite handy that you're able to add in a pause whenever you want, to sort of allow you to do these things, which back in the day, early 3D printers wouldn't allow you to do. This little dark blue section, that's called a brim, and it's automatically created this because this will improve the adhesion to the bed for our piece. So because it's quite a tall piece and there's a lot of movement that goes on with the 3D printer as it's printing, this is a way that it just has more to grab onto, and it'll be a lot more secure. You can change the size of these brims, and there's a few different sort of versions that it would create to add this support, but it's such a handy thing that it adds it automatically at this point. Realistically, if we was to send this to print now, it would create a hell of a mess. And the reason for that is this big overhang that we have on this head part. When the 3D printer gets to the end of this, this shaft and it starts to try and print this, there's nothing for that filament to lie on. It would just literally fall down, and you would end up with a big plastic spaghetti mess everywhere on the bed. So in this case, you would use something called supports. So supports over in this side, as you press that button, there's an enable support mode, and there's a few different supports that you can use to create the structure to support that overhang that you've got. If I hit enable support now, and if I hit slice plate, now you can see that that overhang is being supported by lots and lots of branches, and this really does look like a tree. So this is actually called a tree support. So it's a nice way to minimize support material, because obviously all this will be wastage after, and it's slightly quicker than a traditional support, which I'll show you as well. So I'm going to turn it onto support, but as you can see, all the way around there, it's been supported by those branches now, which is what we need. If I now change the support mode to normal and slice it again. So the way this support material works is it does a big hefty block. If I bring the top down there, you can see that it's a fanned like grill structure, and it would go all the way up the side of the piece right up to where it needs the overhang support. As you can see, it's quite big, so you do use a lot of material up. And because we're obviously looking after the environment as much as possible, I would select tree for this case. But it can depend on what you're printing. Sometimes tree supports won't be exactly what you need and it might not work. But for this, it's quite a simple overhang. And as you can see there, it looks like it's being supported all the way around quite nicely. The downside of having like an automatic support like this is if I actually turn to the underside, you can see there's a big green support in this middle section where all our threading is. So if I move it down, see all that threading and the top of that void has been supported. This can be a bit of a pain to remove because we obviously want this nice hole for a bolt or another piece to be screwed into. So we can try and select for this area not to have any supports in. So if I go back to our prepare view and bring it down just like that, there's a tool here called supports painting. And if you left click on an overhang like this, it will turn blue, and that is an area that you're telling that no matter what, you want supports there. But if I go over to this side and actually click the right click, it goes red, and you're actually telling that you don't want any supports in that area. Okay, so what I'm going to do is inside this section here, I want to paint using the sphere tool red, because we don't want any area in here to have any supports. Sometimes you can use the paint bucket fill, but I have found because we've got a thread section going on there, it can get a little bit messy. Just remember to obviously use the red right hand button on your mouse, because otherwise it will go blue like that, which will add a support. So just really carefully making sure you've got everything in there, because it can be a bit finicky. I think it's just because we have got quite a finicky little thread going on there that sometimes it can throw up some problems. So I've painted all inside that area red. So now if I slice the plate, and it's just loading up, brilliant. So now you can see that inside that threaded section, we've got no supports because we don't really need it for that part. So when this finishes printing, we are able to take it off, break off the tree supports around this outside, and we won't have to worry about any of the inside threads being affected by these supports. So just quickly summarizing some of the basic tools that we have on the left-hand side here. If I go to quality, this is where you can change the layer height. So I said a standard for this would be 0.2, and you can change that smaller or larger depending on what the 3D printer that you own or a business owns is capable of. A seam is something, if you see this big white line, basically every time the hot end that's squirting the plastic out comes up a level and starts again, every start point and finish point will create a little tiny blob, barely noticeable, but if it's in the same place all the time, you'll see quite a clear seam. For this project, it isn't much of an issue. Aesthetically, it isn't going to change anything. That's absolutely fine. But that's set to aligned, so it's automatically finding a way that we can align it. You can set that to say random. So if I hit random and hit slice plate now, you'll see that those white little dots are actually spread all around the piece now from all directions. That might be something that you need, but actually when you have a nice smooth surface, you do actually see these little type pips that of seam that come up and down the length there. So for this, not necessarily something we need. You can have it all aligned to the back. It's just handy to have a bit of a play. So this is in a straight line all the way from bottom to top of the piece. I'm quite happy with that, so I'm going to leave that as it is. When you come over to the strength tab, this is where you can add stability to a piece. And once again, it all depends what you're printing and where you want the strength to be on a piece. But generally, the outer shell on the outside, you can select how many lines of filament thick it is, how many wall loops. So at the moment, if I come down here, you can see that the outside wall is basically made up of two lines. There's the yellow line here and this outside orange line. If I wanted to make this a bit more sturdy on the outside edge, say if I wanted to go to 4 loops, I'll select 4, and then slice the plate. And now you can see that edge is made up of 4 paths of filament. Obviously, the more you have, the longer it'll take to print, but it's that quality versus speed discussion that you're having. It all depends what you're making and what you need it for. With regards to a prototype, more of a visual prototype, 2 layers would be absolutely fine. The red section that you can see in the middle part, that's the fill. I'm just going to close this down so we can see it a little bit better. This is the infill pattern. This currently is set to a grid, so it is literally, other than the trees there, if I rotate ever so slightly so we can see this, it's just like a boxed grid that goes from top to bottom. This gives stability in sort of the left and right and up and down that way, but it isn't giving complete stability along the other axis, on the axis. So there's few different patterns that you can have inside, like honeycombs. Say if I select honeycomb just to show you what it's like. So you can see now that that's a honeycomb section all the way through. But still, that's giving you stability in a particular axis, but not necessarily the other. So I like to use, for a print like this, I like to use cubic. So if I show you cubic gives you a support of a grid, but it also splays out as it goes along. So it's actually building like a nice 3D grid inside, and I find it gives more support on all axes that way. But like I said, it depends what you're printing and what your needs are to what kind of infill that you will use. And you can change the density of it. So say this is quite an open density set to 15%, but say if I went to something like 50% and then hit slice plate, it's going to do a lot more printing, but can you see it's a nice finer pattern inside there? That would make it really strong. You could go to 100%, which would make it pretty much a solid piece of material, but you'll be using a lot of filament and it might be excessive in time as well. It would take days to print. So where we were, let's just have a look, was it 15% would be pretty good for what we're looking for here. It only uses the infill where it needs to, otherwise it'll be an outside wall. And you can also set the thickness of the first initial layers at the bottom, so you could actually have a thicker wall on the base, and also the top as well. But as we've got a nice big cone on the top, we won't necessarily need any extra support on the top surface. We've already looked at supports, so I'm just going to hit others on this section. And there's different variations. You can change how many skirt loops there are, and that bottom blue section is what we're calling a brim or a skirt. And there's a few different versions like rafts that you can do, and they all do different things for different purposes. You can change how the wall looks as well. So this is a nice flat smooth section, but you can actually do random movements within it to make it what they call fuzzy and things like that. But we don't really need to touch any of these things for simple prototypes that we're doing now. So just to double check, we know that we've got no supports down in that center section. I'm quite happy with all the settings that we've set for this. So it's just a case of exporting it to the micro SD card, to taking it to the 3D printer. So the way you would do that is just hit this top section up here, and you can change it to export plate sliced file. So this plate here, and then you would just click it. You would save the file, put it onto your micro SD card, and then you could take it to the printer, and as long as the printer is all set up ready to go, it'd be all good to print. So I hope that helps. You can get a lot more granular in this slicing software. There's a lot more things that you can tweak and get into. But with the Bambu Lab printers, they tend to just work as is really well, especially for the prototyping we're trying to do at the school. So I hope that helps. Good luck creating your plumb bobs, and hopefully that sparks a little bit of interest into 3D printing in the future. Thank you.